We're asking engineers to be both brilliant engineers and excellent at the law. It's a lot. But here's the interesting thing about the law, right? When systems fail, when they break, when they collapse, when bridges fall or buildings topple, nobody ever says it was the lawyer's fault. Nobody, right? When a building collapses, when a bridge fails, it's because we didn't design it properly or because we didn't build it properly. It's the engineer's fault, right? It is not the lawyer's fault. And that's the nub of the problem, right? We're allowing lawyers to define design decisions for how we build safe, ethical, trustworthy, private systems. That doesn't work, right? Lawyers don't understand any of the acronyms we saw on the screen a minute ago about distributed data infrastructure. So how can they write laws about these things? So the result of that, of course, is that only engineers have the power to fix privacy. The problem is that we need to understand privacy to fix it. And that's where the issue starts, right? You need to have sort of power tools for privacy. That isn't the way we do it today, right? Today, if any of you faced privacy in a team that you work in, it's probably the lawyers giving you impact assessments or risk reviews or product reviews or considering things about like definitions in the law about what constitutes a risk. That isn't making the system more private. It's not making it safer. It's not protecting a user. It's just a lot of paperwork, right? Paperwork doesn't keep buildings standing, right? So engineers need tools built for privacy. And for me, that's what I've spent the last 6 years of my life doing, only this problem, trying to understand how we take complicated, esoteric legalese and turn it into something that we can apply in deployed applications, right? Those tools are called FIDES. In fact, we launched the newest version of FIDES today, FIDES 2.0. So we launched the first version of FIDES a year ago at the Web Summit in Portugal. It's now used by a whole bunch of the companies that are out here and most of the big tech companies that you all know or work for. And it does a whole bunch of things for them in relation to privacy. So what I'm going to do today is hopefully give you a little bit of a demonstration, a bit of an understanding how these tools can help you to create sort of privacy or better tools for you and privacy superpowers within your organization. All right. So the first thing we're going to look at is just a quick example to show you how powerful FIDES is, right? We're going to go straight into it, right? We're going to look at privacy rights automation with FIDES. Sometimes you'll have heard this referred to as subject rights or DSRs or access requests or erasure or portability or the right to rectification. These are all the lawyers' words. Practically what it means for engineers is we need to be able to retrieve and erase users as efficiently as we create records in distributed systems. Right? When a user registers for an account on anything we've built, we can pretty much guarantee we can propagate that data into transactional databases, data warehouses, and third-party systems in seconds. Try deleting it that quickly. It's almost impossible. And we all know the reasons why. We don't really know where it went. We don't know what is and isn't personal data. It's a super complicated problem. So what we're going to do now is just go straight into how FIDES can do that. If you want to follow along and try this, you are welcome to. So you can do this directly from the source on GitHub, or there's a Python package. So you just need to be running a reasonably current version of Python and Docker 20, 10, 17 minimum, please. Basically, I've already got this running. So I've installed the Ethyca FIDES tools and project locally. Hopefully they don't crash my Docker containers, but we'll see. And I've sort of made some minor configuration changes for me to use locally, and that's it. So jumping out of this for a second, I'll show you what we've got here. Well, we're running it locally, a bunch of containers. And this is what you get when you deploy it. So just to explain to you what is here, there's a sample project. So there's the FIDES administrative UI. So that's the sort of UI tool you use to manage FIDES and the tools that exist within it. There's the server. If you're curious, it's all Python-based. There's a Postgres database and a Redis cache, just sort of powering FIDES, as it were, right? And then on the right side, we've got what we call our sample project. In this case, it's called the Cookie House. And the Cookie House is just a fictional e-commerce site that does exactly that, right? It sells cookies. And of course, it collects personal data because it sells cookies. And that personal data flows into, in this case, MongoDB and Postgres. And it could flow into a bunch of other third-party systems. Now, we as engineers have been tasked with ensuring that when a user says, hey, delete me from the Cookie House systems, that we do that consistently, or retrieve my data for me, okay? So let's look at the tools that we've got here. We've got the FIDES control panel that you're looking at here. Okay. So this is literally the UI that allows you to manage privacy requests. Actually, we'll just open it fresh here. please, no Docker failures. Okay, there we go. Okay, so this is the admin UI that's sitting on top of Fides. There's a bunch of features we'll go through in a few minutes, but the bit we're looking at right now is for a non-technical user, like a lawyer or maybe customer support, to be able to review requests coming from users, right? To review a request from a user. The next is our Cookie House website itself. And the next part of it is our privacy center. So this is just a React application. It's actually Next.js. It's just sitting inside its own container alongside the Cookie House website, and it's wired back to the Fides orchestration tools. So in this case, we could purchase a product. It's a very simple flow. Add some data about ourselves, right? And just get stored in Postgres and propagate it to MongoDB and goes to a bunch of other places afterwards. I could create one quickly, but in the interest of time, I'm just going to use a test user that's already in here. We've got a user called Jane at example.com. So I'm Jane at example.com. I'm going to go to the privacy center. I'm going to ask to run an access request. So I'm just going to put in my name, Jane at example.com. Phone number is optional. Now you'll notice here there's no identity verification. So out of the box, Fides supports two factors, right? So you can send an ID to a known device or an email address or a phone number, but I haven't got that configured because it's running locally. So I'm just going to submit my request. So this is me, Jane, saying, hey, Cookie House, give me a copy of my data. That's my legal right. I want my information. Now, we could then get a ticket in Zendesk or Jira and then probably go and retrieve data from a bunch of distributed systems, but that would be painful, right? Hundreds of systems, lots of data. So instead, we're going to let our customer support team process the request. As long as it doesn't crash, correct? There we go. Sorry, this is running locally and a little bit slowly, so apologies. Let me just check my containers here. Everything looks good. I'm just going to sign out here for a second and log back in. Sorry, because I think that might have just a session issue. There we go. Okay, we've got two privacy requests because I submitted twice out of impatience. I apologize. Again, for those that weren't paying attention, it's running locally on my computer and Docker is struggling to keep up, so I apologize. So you can see here that two separate timestamps, one at 11:38:54, one at 11:39. If we reveal the PII, we can see they're both for Jane at example.com. Now you can see they're filed against a default access policy. That means the kind of privacy request that's going to be running on this one, okay? So what I'm going to do here is just approve those. And you can see here, it's immediately generated a JSON object into a just temporary directory locally. When you configure it with a mail server, it can send it directly to the consumer in an email, or it can send it directly to a link via SMS so they can download it. But here we're just downloading it locally so that we can look at the package. If I just open this up, I'll just tidy it up a little. You can see that what it's returned here is a formatted object of all of the user's data from both Postgres and Mongo, okay? So there's a bunch of things happening in the background that we'll talk about in a second. But in simple terms, right, what we've been able to do here is spin up a couple of containers that have a data orchestration engine designed to execute privacy requests and highly configurable, right? So you can configure the type of de-identification you do, whether it's HMAC, concatenated with random number generation, or a bunch of other things you want to do, right? You can specify the specific fields within a record set that you want to delete, a bunch of other clever things that we can talk about in a moment. But at the highest level, what we've done is stood up a system that allows us to receive a privacy request from a user, verify their identity if we want to, process that request, and execute it across all of our distributed systems, right? In this case, just Postgres and MongoDB. If we wanted to, we could actually connect it to other things. So you can see here we've got MongoDB and Postgres connected. If we wanted to plug it into something else, we could do that also, okay? So let's talk a little bit now about how configurable this is, right? So in particular, I'm going to jump to, we'll come to this in a second. Let's talk about policies. So all of this is driven by policies. They're all written in YAML, and we'll talk about the YAML definitions that are powering feeders in a moment. But in its simplest form, it's very, very configurable, very lightweight, very readable YAMLs that allow you to define what you do when you receive an access for data, an access request, an erasure request, portability, rectification. So you can configure and design how it executes against systems, what kind of sort of dependencies there are in the identity graph. So whether you need to retrieve a sort of primary key from one system and use it as a foreign key to another. So you can configure all of those so you've got a consistent model of how you execute requests across your distributed systems. And the same for erasure, right? So we can create a policy that defines the type of erasure we'd like to execute. So whether it's using sort of basic hashing, SHA, HMAC, etc., all of those are configurable in here in these basically what we call our sort of request policies, essentially. Okay. So again, what we've done there is a very simple example of deploying it in 5 minutes. Well, it took a little longer because the containers are slow, and running a request end to end. I'd encourage you to test it. It comes with a bunch of pre-built connectors, right? So you can plug it into whatever you want to plug it into. And it also has an open source interface that is designed to build connectors of any kind that you want. So you can essentially authenticate against any third-party system and generate an orchestration for it. Okay. So let's talk a little bit more about what privacy engineering means. Remember, what we've covered there is a simple example of how powerful those tools can be and how much time they can save you. Everything you've seen is just free out of the box. You can spin it up today. What we're going to look at now is a little bit more deeply what Fidesz does. So the first thing is it can be deployed anywhere. I'm running it locally, but you can build it and deploy it anywhere. There are users running it in all of these cloud providers and on bare metal, so it runs anywhere you like. And it can connect to anything, right? So what I mean by that is there's a bunch of pre-built connectors in the open source, right? So connectors for things like Salesforce and HubSpot and whatever else you might have. And it has effectively an open source connector builder in it. And that is to say the composition of a connection is a data model or a data set and essentially logical execution. So there are two YAMLs that compose a single connector, super simple. So you define the model and the order of which you want to execute against that model, super simple. So anyone can create a connector. Typically takes about 2 to 3 days to create and test a connector. We built lots of them and you can make your own. So you can truly connect it to anything. Then what you haven't seen yet, which sort of augments its capabilities, are a bunch of automated tooling that sits on top of the core language. And we'll look at that in a moment. So the system scanning, so there are infrastructure and resource scanners built in. So it'll scan against AWS, GCP, Azure, and identify system resources like RDS, buckets, anything else, and generate a map, a metadata view of those systems. We'll look at that in a second. So you can basically scan and look for, you know, what your lawyers will call shadow IT, right? Stuff that's deployed that they don't know about. Once you have scanned to identify systems, there is a machine learning data labeling tool built in. It uses the Fidesz taxonomy, so the Fidesz language, which we'll look at in a moment, to label distinct fields of data. So essentially you can point it at something like Postgres or BigQuery and it will generate a data set, so a data model of that system, and label each individual field. So none of that manual spelunking through these things to label them to make the lawyers happy, right? Because it's using a standard for privacy. And then there's a way to maintain those data models in your projects in Git, because all of this is ultimately maintained in YAML files. So it synchronizes to a system of record in the Fidesz server. It sort of works a bit like Git, but for privacy, right? You maintain data models, you synchronize them in your projects. When you make changes to anything you're working on, when you commit it, those data model changes are shipped into Fidesz, and that augments the data model that the organization has for compliance. And then the last part of that is, as you've seen, it provides privacy request automation tools, right? So it uses that model of where data exists across distributed systems and the tools to maintain it to allow you to orchestrate tasks consistently. So those are sort of components of Fidesz. Now let's talk about like what's actually under the hood. So there's a language called Fidesz-Lang. Fidesz-Lang is a lightweight declarative style language. If you're familiar with Terraform, which you all are, it's the same thing, but for privacy, right? I don't need to know a whole lot about what a cloud environment or a cloud provider does to deploy something if I use Terraform. I can essentially make a demand of Terraform, right? With very basic syntax, I can say, hey, give me an instance of this size and dimensions for these purposes. I can do the same here, but for privacy. I can basically say, I know nothing about LGPD in Brazil. I don't know anything about the GDPR. I don't need to. I've got privacy superpowers. All I need to know is I'm handling some names and phone numbers and email addresses. And I can declare that in a way that's easy for me as an engineer. And Fidesz takes care of the rest. So the taxonomy has been a work between academic institutions, large tech companies, and Ethyca for the last 5 years. You're welcome to extend it, to use it, to modify it, etc. And you can find it at Fides/taxonomy. So that's driving the tools. And we talk about it as a taxonomy, but it's essentially an ontology, right? There's a syntax for how you write grammar in this language. It's very simple. So let's look at the components of that. There are data categories. It sounds obvious. These are the whats. So what kind of data am I processing or collecting? Names, email addresses, behavior data, phone numbers, etc. And the syntax is very simple. Like, it's dot notation. There's a small amount of snake case that is snuck in there, but don't hold it against us. There's some very long legal terms to cover. So basically, we've got data categories. So what kind of data am I processing? Data subjects are the who. Is it like a customer? Is it an employee? Is it a patient? Is it a voter, etc.? Then you got data uses. So how is the data being used? A very simple example that we can all understand is, I am using email addresses and first names for personalized email marketing. So the use is personalized email marketing. That's the what I am doing with the data, right? And these three dimensions are what you need to know when you think about privacy risks. What kind of data am I dealing with? Whose is it? And what am I doing with it? Okay. So you get the sort of core primitive concepts of Fides. So there are organizations, and think of these essentially as the context in which you operate, right? The scope. So it could be a team, like the engineering team, finance department, or it could be the entire organization, Acme Inc. Okay. So you can define many organizations. Organizations can have their own data models. They can also have their own policies and rules to be enforced on those systems. And then you've got systems themselves. It sounds obvious, but systems are essentially what they sound like, right? Things that perform logical tasks, right? It could be an entire application like a monolith. It could be a single service in a service-oriented architecture. It could also be a database. Technically, a database is a system, right? So there's sort of declared entities or resources on a map, right? And then we have data sets. In privacy, most people don't care about this. Your lawyers don't care about the sort of construct of data sets versus systems. What they care about is what kind of data is in a system. Then you've got to try and teach them that that's not how systems work. Data moves around all the time. So actually, data sets are a data engineering paradigm, right, that allows us to understand that we can have collections of information that might be available in multiple systems for multiple uses. So data sets exist in Fides to allow us to declare that these types of data might exist in Postgres or Mongo or somewhere else for these several other purposes exposed to multiple systems, right? And then we have policies, and policies are pretty obvious, right? They're the commitments we make. We've all seen the privacy policy for the company we work for. I doubt any of us have read the privacy policy for the company we work for. But it has essentially all the promises that business is making to its users, right? So policies in Fides are the ability to take that promise and convert it into something you can actually enforce. So it's actually something you can empirically evidence and prove for the business, okay? So with Fides, you can do a bunch of things, right? You can declare the type of data you're using, for what purpose, and you can write a bunch of policies, a bunch of clever stuff, right? So let's go and look a little bit more in detail about how you write labels and how you can run CI checks to enforce policies. All right, so what I would like to do, but I'm not going to risk it, is spin up a bunch of different Docker containers and show you some other tools running, but I think based on how slowly the others are running, that might fail me and I'll get egg on my face. So let's walk through it slowly and we'll try and explain what's happening. So in this fictional example, it's still a fictional e-commerce application, right? It's our Flask system. We've got I'll zoom in a little bit here, make it a little easier to see. So we've got a data set that represents Postgres in this case. And you can see it's a very simple data set, right? It's got 3 tables: products, purchases, and users. Could be a collection or a model that represents anything, but it's very simple. We then have a YAML that represents our system, right? In this case, it's our fictional e-commerce application that we use to simulate e-commerce. That's what it is, okay? Super simple. So again, the corollary for this is what we're looking at here is the same thing that we're seeing in our administrative UI, right? It's the view of systems that exist and what we can map effectively, okay? So we can manage these in the UI if we're lawyers, or we can manage these in the in our projects in Git directly via YAML files if we want to as engineers. So they're all synchronized consistently, so an engineer can just update models, and lawyers get reports from that, and we'll look at the reports in a second. So in this example, I'm an engineer working on this fictional e-commerce application, and I've got 3 tables. We'll look at the users table. We've got 6 columns or fields, if you will. We've got created at, right? We've got email, first name, ID, last name, and password. Super simple. If we examine these in a little bit more detail, created at has been labeled using Fides labeling as a system operations data, meaning it's not personal data, right? Timestamps are not about people. They relate to an action or an event that has occurred in a system. So it's a piece of system operations data. I could also just declare it as systems data, more generically or abstractly, right? The equivalent for email is here, right? I've got a user email address. Actually, the syntax has changed. It would be user contact email. So that would be me just saying this is definitely an email address, okay? Now, as a developer, I'm working forward. I'm making changes to code base, and I decide I'm going to collect something like health and medical data. So I'll declare that as health and medical. So here's an engineer. Instead of filling in a form to send to the legal team for a risk review, I'm just annotating or labeling my data models as I make changes to them, whether I'm adding a column to it or I'm changing the type of data that I'm handling. Now, I don't have this running with any Git hooks locally here. This is all local and can't rely on the internet too easily here. So in this case, I can't commit it. But what would happen is when I am committing this, it's running an automated evaluation using the Fides server. So basically what happens is it looks at the annotations that the engineer has committed, and it checks them against policies that the business has written. So lawyers write policies, engineers just write code. And in this case, we have a policy in this system that is actually pretty simple, right? Let's just look at it. It's got two conditions or rules. One is that we minimize the use of identifiable data, and one is that we reject the use of sensitive data. So we've decided these are two rules we want to adhere to as a business. Okay. So let's look at the first one. We'll look at minimizing the use of user identifiable data. So what we've said is we're going to reject the collection or use of any identifiable data, any of these types of categories, right? So identifiable or provided or derived data for any of these uses. And if any of these conditions are met, it should be rejected. So it generates an evaluation in CI, an automated check in CI. It generates a report, and it warns the engineer that they are not compliant, right? It doesn't stop them from working, just notifies them they need to change something. The equivalent here is for risky data, right? Sensitive data. So here we've said, well, if we're attempting to use any of these categories of data, so biometric, children's, genetic, health and medical data, for any of these purposes, advertising, personalization, third-party sharing, if we attempt to do that, that's a hard no. We reject that. We don't allow it. So there's two things happening here, right? One is that engineers are able to update the data model as they work forward. The beauty of this, right, is you're not asked to go back and label BigQuery 6 months later, tackle 4,000 tables. If you want to, you could use the automated classification tools, and they will provide these labels automatically, okay? But when you do make a change, and you commit that change, it evaluates it against the organization's policies proactively to make sure it can't get deployed to production if it doesn't meet all of the organization's standards. The equivalent of a unit test, not for security, but for privacy, right? Make sure we meet our privacy conditions. And each of these commits augments the data map that we see in production. So that means that our view of systems that we're able to map is presented back to us here. Now, unfortunately, I think our containers aren't running quite right today for some reason, so. Here we go. So what you'll see here are all of the systems that have been mapped in this. So the cookie house, our Postgres database, and our marketing systems. And the data sets that are associated with them are mapped here, right? So the lawyers can look at one of these and say, I've got an example data set for Postgres. It shows me the fields of the address table, the employee table, the login table, the orders table, et cetera, right? And the category of personal data that is associated with them. So for an engineer, we could look at this UI and we can continue to label things here, right? I could update the label here if I wanted to some other category of personal data. But that isn't my goal, right? Like as an engineer, I'm not going to live in this UI. I just want to be able to ship stuff as quickly as possible. So changes that are made to this YAML are synchronized to this system of record, and allows us to generate these centralized data maps. So no more data maps in spreadsheets, no more labeling stuff for legal teams. Just make minor changes to data models. You can do this directly in YAML. You can make the annotations into things like sort of SQL Alembic, protobuf files, et cetera, and maintain those models for privacy purposes. And they then synchronize so that you can execute request orchestration for privacy against those consistently. Okay. And ultimately, what's driving all of this, as we talked about, is the taxonomy, right? The ability to label categories of personal data either manually or automatically. In this case, we're using the default FIDES taxonomy. You can obviously augment this with your own labels or categories of data or definitions of data for the use in your business, right? Like you might not do email marketing, it might be something else, for example. But it covers most of the common conditions for privacy under the regulations. Okay. So, what have we covered here? Okay, well, we've done a bunch of things, right? We've run a privacy request in FIDES very quickly. We've seen how simple that is to get up and running and connect to systems and execute a request. So if you didn't want to know anything else about privacy, you could run privacy requests for free from this for eternity without doing anything else. The next thing we've looked briefly at is the FIDES taxonomy, how it's structured and how you label data models and maintain those. And then we've looked at how you would enforce policies in CI. This is just a very brief introduction to what you can do with FIDES. Ultimately, it's yours to play with. We'd encourage you to do so. I would ask you to borrow from these tools and use them to make your technology systems better, safer, and more trustworthy for the users that you're building them for. Thank you for your time. I really appreciate it. Sure.
If I understand the workflow correctly, if you have a website with a Facebook, whatever company is, they would be running FIDES internally, and their API will call FIDES when a request comes in. Now, the reason I'm asking the question is this: how would you regulate two things, right? How do you regulate that if I live in Raleigh, North Carolina, the company is in California, how do you know to apply CA
Great.
standard versus GDPR standard?
Great question. Yep, great question. So let me tackle those in the right order. I'll tackle the second one first, if that's okay. So this is how do I ensure that someone doesn't submit a request for Cillian@gmail.com versus you, right? So and this is where the law, the privacy engineering law thing comes against the engineer, right? So the law is very clear. A business, so engineers running a system, are legally responsible for verifying that they're confident that John is John, Jim is Jim, Jane is Jane, right? The method of identity verification is up to the business to decide. The most common method that's used for automated identity verification is essentially like a second known factor, meaning if you provide me with an email address as a primary identifier for your request, right, like Cillian@gmail.com, I'm going to send a unique ID or code to that inbox. It's assumed that if you have access to the inbox, you are the user. Now, one could argue, of course, you could have compromised the inbox. You could be phishing on behalf of somebody else. But is that is that a sufficient burden for the business to be responsible for, right? So that's the first thing. You could decide that you want to verify it manually, right? You could go through a whole mechanical Turk, but I don't think anyone wants to do that. Then the second point you raise is how do you specify policies? So it's important to understand in this, you can write policies to execute privacy requests for the GDPR, the CPRA, the LGPD, all of that alphabet soup, right? You can actually assign them in the UI based on a number of conditions. One is you could assign it manually. So you can actually look at a request and say, I've decided that Jane is in North Carolina, I'm going to honor the request this way. So manually. The other two are you can configure it to use geolocation via IP address. The problem with that is it's sort of like a privacy problem within a privacy problem. Using IP detection to identify location has two issues. One is it may not be accurate. The other is it's actually a breach of privacy if you haven't got consent for it, right? So that's a challenge. And so the third option is explicit attestation. So you ask the user in the privacy center. So you can actually configure these privacy centers to have, not to show you very commercial examples, but if you look at Away Travel, the luggage company, when you go to their site, they actually configure it with a form to intake a bunch of data about the user. So that privacy center I showed you for the cookie house is just an example. You can configure that to accept any parameters that you want to verify identity, right? Totally. Yep, exactly. No problem. Thank you very much. Thank you all. Right. Correct. Yes, correct. So the policies that you can construct in FIDES are designed to tackle just that. That's why it's built, right? Because it's unfair to ask an engineer to make that decision. Like, is city personal data, or would it be if it was associated with these things? So FIDES ships with a bunch of policies that make those decisions under various laws. Like I can answer that for you concretely and tell you that the GDPR says that zip code or postal code in isolation is not personal data, but a zip code with the first line of your address is personal data. So those two being used together would constitute personal data on behalf of the user. So you would either need to both erase those or return them to the user, or you might need to have a retention policy that disposes of them after 30 days. Those conditions exist in the system already, so you don't have to do the legalese to make that decision. All you have to do is label the data accurately. Yes?
Do the policies handle oddball exceptions? Like, say, for instance, you've had a user that's grossly violated terms of service, and you need to be able to make sure that they're banned for life. So that's one of the exceptions to GDPR and DRQ.
Totally.
Report their personal information and never come back.
Totally. It's a really good point. So just to reiterate for everybody, there are conditions under which you might want to keep data about a user that would be legally permissible, right? Like fraud, massive fraud. We need to know that we identify Jane Doe forever so they don't come back and defraud us again, right? So even if they ask to be deleted, we have a legal right to keep that data, right? That's completely permissible. So in that scenario, this is the elegance of the solution. Provided you have a consistently labeled data model, you're not looking at a system. Like, you don't have to cherry pick a system like the fraud detection system. You can just say, well, we actually retain names and email addresses and phone numbers for the purpose of fraud detection. And systems labeled with fraud detection that have that data will be excluded from an erasure request. So effectively, if you can think of the patchwork of labeling that you're doing as you ship work in your CI pipeline, augments the data model, policies sit against that and are executed consistently. So, and the dimensions of those are the categories of data, the purpose of use, and the risk that poses. So you could exclude fraud, for example, by default. Correct. But in that scenario, like businesses that ask that regularly, which is common, is that they are using fraud detection systems. Like gambling companies do it regularly. They retain data about users where they think there's a risk of fraud. And so what they will be doing is writing a policy that excludes the erasure of certain fields of data from that fraud detection system, for example. Yes? Sorry, it's a little hard to hear you. I'm so sorry. Yes. Yeah, sure. So in the open source project in FIDES, there are a bunch of scanners built in, and they ship completely free, right? So they vary in their implementation based on what you're trying to detect for, right? Like there isn't one tool that could detect all, air quotes, shadow IT, right? So in the case of the scanners that ship in FIDES, there's what we call an infrastructure scanner, which is effectively looking at cloud infrastructure, and it's identifying distinct resources like individual buckets, data storage systems, deployed applications, et cetera, and it returns a map of those. So it returns a metadata model that looks a lot like these data models, right? So it looks a lot like this data model, but you can visualize it in the UI, okay? So one's an infrastructure scanner, the other is what we call a system scanner, and that's executing against SSOs and sign-ons by domain, so that you can identify third-party systems, because your sales team have bought like outreach for sales, but they didn't tell you, and you can't see it, but you can see logons. So it's detecting logons. So we've built a bunch of scanners that use different methods to inspect and observe what data might, or what systems might be connected to an organization. So infrastructure scanning, system scanning. We are in the middle of adding a front-end scanner that's looking effectively at data flows or data egress from a website, just like a web application. And the fourth, which isn't honestly in the open source, is the most sophisticated one, and you'll all be familiar with this. It uses an eBPF implementation, right? So it's a kernel level evaluation of transactions. It's effectively introspecting past the TCP layer to the header, to the HTTP layer, looking at the source and destination systems and the message body. It doesn't do anything with that other than Lex the categories of personal data that are flowing. So it allows you to distinctly see I've got like Nginx, Postgres, MongoDB, and Stripe, and these are the categories of personal data flowing through them. Endpoint agents work slightly differently to eBPF, right? Like that's the challenge. So it's why everyone in security gets uncomfortable with endpoint agents, right? They're like pretty aggressive implementations. eBPF is a really fascinating project, right? It's been around about a decade, but only really become something of interest to the security field in the last 5-6 years, I'd say. Essentially, it allows you to deploy, you could say a Linux or like a kernel level sandbox into Linux environments. and allows you to inspect any transaction passing over the kernel. So it's pre-TLS, so you don't need to like break open secure packets, right? Like it's before anything is encrypted, and allows you to see the entirety of the header and the message body. It's a very powerful tool if used in the wrong hands, but in the case of Infides, it's just used for labeling. Yes, hi. Yeah. Yeah, finished. Yeah, we keep adding loads of connectors, but yes, it's finished. Yep. Sure. The short answer is you don't have to have a stricter schema, right? But you're right that it's principled on some kind of schematized view of a data model. So if what you've got is ultimately like a document store with lots of documents that are distinct, like so let's not take Mongo, let's take something really tricky. So let's take like JSON or Avro or Delta Parquet in an S3 bucket, right? That's a real problem because actually what you really end up with is a schema per document model, right? That's what you have to end up with. We have been building implementations that do just that. So like you end up with a schema per document. But the TLDR and warning to any engineering team implementing it is, well, if you keep generating like truly schemaless, data models, you're going to end up with a very, very messy view of personal data, right? Like your map becomes pretty wild, right? So, but yes, it's supportable. And it's technically not, it is schemaless technically, right? Like it is just key value pairs in YAML to represent data models. So you could model anything. The issue is the flexibility and therefore the degree of accuracy that you're going to have over like a very distributed set of systems. All good?
Get a certification process to verify that company that provides this data is actually accurate to what's been collected yet. I've not heard of anything like that.
There is no, there are no, well, so the law is really tricky about this. Regulators will not certify privacy technology, right? So the best they will tell you is that they believe these tools to meet the regulations. These tools have been reviewed by the CNIL, which is the regulator in France, the ICO in the UK, the DPC in Ireland, which regulates most tech companies. I can't say I can't get myself in trouble by saying they just love our tools. They like lots of tools, but these are considered, in many respects, the most sophisticated way to solve privacy. Right? Most privacy is done by scanning systems in production. That's all it is, right? Like it's sort of point in time, constant compute with machine learning to classify things. This attempts to make it a sort of part of software development that simplifies the issue and lowers the risk. And that's what we should all be trying to do with privacy. Right? No problem. Thank you very much for your time, folks.